Everyone in this room has something in common. Well, 99% in common. We as humans share over 99% of our DNA. Yes, you are all unique, but not very. It's 96% with chimpanzees, our closest relative, 50% with a banana. You and the grapes in your wine share 24% of your DNA, and it's 18% with the yeast in your beer. But it's not just the similarities which are interesting, it's also the differences. And genetic testing can be used to tell us about these differences, about what makes us unique. I'll tell you how. The human genome contains over 3 billion base pairs of DNA. And we've learned a lot by looking at just the 10 million which explain the common differences between us. This 0.3% can explain why some of us are different to others. Why some of us have more freckles than others. Why some of us have blue eyes and others have brown. Why some of us, few here, have red hair or curly hair. And some of us maybe no hair left at all. And about your body, why you metabolize caffeine faster than others, or if you're a night owl, biologically speaking, or if anyone in this room happens to be naturally resistant to malaria. And most importantly, your DNA can be used to predict your individual risk for things like heart disease and various forms of cancer. Now you may be thinking, why would anyone even want to know that? Birthdays, and lots of birthdays. I personally love birthdays and I want everyone here to have as many as possible. So I'm going to share with you a few of the really cool things that we can do with that genetic information to help you live longer and better. The great news is this: for the serious diseases, if you can predict your individual risk, you can do something about it. We can catch and treat many diseases early, and we can avoid some entirely. More and more medications can be used to target your genes. That takes the guesswork out of which medicine to prescribe and to whom and when. And that means getting the right treatment to the right person as early as possible. What about a diet that's tailored to your genes? Or being told in advance which checkup you need to have, where and when to get it? These are the sorts of things we're trying to bring out of the lab and into your lives. Okay, so the things we know today can help you to live longer. But what about tomorrow? What does the future hold? And this is where things start to get really interesting. We have gene therapy technologies where we can take a gene, put it into a virus, and deliver it straight into a cell, where it starts to produce a protein. This is most often used to treat simple genetic conditions, the sort that are found in younger children. On the horizon, technologies like CRISPR will allow us to edit the genome directly, putting good genes in and taking bad genes out. This could really revolutionize medicine and also bring us designer babies. But we're not there yet. Disease is complex, and you probably can't see this, but our precision is a little limited still. It's not just the genetic factors that we need to consider, but also the epigenetic factors. And the environmental factors also play a role. So if that's the challenge, what can we do? What can we do to learn more about this complexity and to understand disease better? Well, this is where I think all of you will come into the picture. Because we need to go bigger, much, much bigger. I predict that in the next 5 years, most of the people in this room will have at least one genetic test. If you're the suspect in a crime, maybe a couple. It's because by testing lots and lots of people, we can find even the smallest differences between people. And by zooming in on these differences, we can help to unravel some of the complexity that underlies some of these very confusing diseases. We hope to build a genetic map, not just of the big and serious ones, but also things like the headache and hay fever. We'd like to understand how they all work as well, and we want your help to do that. It's said that the first person to live to be 1,000 might already have been born. I'm not sure about that, but before you can get to 1,000, you have to get to 100 and be in pretty good shape. And I can promise you that genetic medicine will have a big role to play in that. Thank you.